On October 30th, something incredible happened. Far out in space, hidden in the sun's blinding glare, a faint smudge of light began to emerge. This was 3IATLAS, an interstellar visitor, a comet from another star system. It had just completed its fiery loop around our sun, a moment called perihelion, and was now starting its long journey back into the depths of space. Traveling at tens of kilometers per second, it's a cosmic messenger, and we're finally getting a good look at its story, written in photons and plasma. As soon as 3IATLAS reappeared, mission analysts across the globe jumped into action. Their first move: use the SOHO spacecraft to take hourly pictures, tracking the comet's brightness. The initial data was thrilling. The comet was a little dimmer than expected, suggesting it lost some mass as it flew close to the sun, but it hadn't broken apart. It survived. Within 2 days, another spacecraft, Stereo A, spotted its dust tail reforming, now pointing at a new angle. This wasn't just a simple tail. It looked like it was being fed by at least 2 active jets on the comet's surface, like geysers erupting into space. A comet's tail is more than just a beautiful streak in the sky. It's a history book. During its close encounter with the sun, intense heat caused ices on its surface to vaporize, creating 2 distinct tails. The ion tail, made of charged gas, gets pushed around by the sun's magnetic field, constantly changing direction. The dust tail, however, is pushed by sunlight itself. Scientists use a clever technique to read this tail, fitting special curves called synchrones to its shape. By doing this for 3IATLAS, they figured out that the dust grains were very similar in size to those from our own solar system's comets. This is a huge clue. It strongly suggests that 3IATLAS is a natural object, not some alien probe. We even saw a brief, faint anti-tail pointing towards the sun. This is a cool geometric trick that happens when Earth crosses the comet's orbital plane, and it confirmed our calculations of its path were dead on. Now that it's moving away from the sun, the comet is starting to calm down. Its brightness is fading fast, much faster than you might think. This is because as the sunlight gets weaker, the ice on its surface stops turning directly into gas. It's like turning down the heat on a boiling pot. Soon, the only activity will come from deep pockets of gas, like CO and CO2, erupting from below the surface. To watch this happen, astronomers are using powerful telescopes like the VLT in Chile to study the light from the comet's gas. They're looking for changes in the chemical cocktail, specifically the ratio of certain molecules. Any changes will tell us if the comet is built in layers, like a cosmic gobstopper with different flavors inside. There's also a tiny, but real risk that the comet could still break apart. The same jets of gas that create its beautiful coma and tail also push on the nucleus, making it spin. If these jets are uneven, they can spin the comet up faster and faster. Before it passed the sun, we measured its rotation at about 7.8 hours. If it spins too fast, maybe once every 3 hours, it could fly apart from the centrifugal force. While a catastrophic breakup is unlikely, even small pieces breaking off would cause a sudden burst of brightness. So far, nothing like that has been spotted, but everyone is keeping a close eye on it, just in case. But here's the most exciting part. Every comet carries the chemical fingerprint of where it was born. By studying its light, we can measure the ratios of different isotopes, heavier or lighter versions of elements like carbon and oxygen. The James Webb Space Telescope is waiting to take a detailed look. If 3IATLAS has different isotope ratios than comets from our solar system, it would be definitive proof that it comes from a different stellar neighborhood. A key thing to look for is the ratio of deuterium, or heavy hydrogen. If that ratio is different, it could mean the comet formed in a much colder, more distant environment than our own. It's like finding a rock on a beach and realizing its mineral composition could only have come from a completely different continent. Now, I know what you might be thinking. Is this thing going to hit us? The answer is a clear and resounding no. Celestial mechanics is very precise. At its closest, 3IATLAS will be over 1.25 times the distance from the Earth to the Sun. Mars will be even farther away. The gravitational pull from our planets is basically zero, but while it poses no threat, it's giving us a unique opportunity. Because of its weird, tilted orbit, it's flying through parts of the solar wind that our spacecraft don't usually visit. Scientists are even trying to coordinate measurements from NASA's Parker Solar Probe with any changes in the Comet AS tail. This could give us our first real measurement of how a Comet AS atmosphere interacts with the Sun's plasma stream. As we head into mid-November, the comet will move far enough from the Sun for telescopes on Earth to get a clear view again. Observatories from Arizona to Hawaii to Chile will be taking long exposure images every night. They'll stack these images to make the faint comet pop out, allowing them to measure its brightness with incredible precision. This data helps us figure out how reflective its surface is, which in turn helps us nail down its true size. At the same time, infrared telescopes will be watching it cool down. Just like a hot pan continues to radiate heat after you take it off the stove, the comet's nucleus is still glowing with stored energy. This thermal glow can tell us about the dust around the nucleus and help complete our picture of this interstellar traveler. So, what's the long-term forecast for 3IATLAS? By 2026, it will cross Jupiter's orbit, and by then, it will be so far from the Sun that all its activity will have stopped. It will once again become a dark, silent chunk of ice and rock, fading into the cosmic background. Its trajectory is set. It will exit our solar system heading towards the constellation of Lyra, never to return. In about 9,000 years, it will have traveled 1 light-year. It's a one-way trip. Future astronomers might one day pick up its faint heat signature as it journeys through the vastness of space, long after we've lost sight of it. Each one of these interstellar visitors, Oumuamua, Borisov, and now Atlas, is a gift. They are challenging our ideas about how planets form around other stars. Are they all icy like Atlas? Or are some rocky, or even something else entirely? These objects are building a new library of cosmic diversity, and the best part, all the data is being made public. NASA, ESA, and other agencies are sharing everything they find, so anyone, from professional astronomers to curious amateurs, can be part of the discovery. This isn't some secret government project. It's a global, shared effort to understand our place in the universe. For scientists, 3IATLAS isn't a source of fear. It's an amazing, unplanned experiment. It's a piece of another solar system, delivered right to our doorstep, where we can watch it interact with our Sun. Seeing the same laws of physics at work, gravity, sublimation, radiation pressure, confirms that the language of nature is universal. It is a powerful reminder that even the greatest mysteries of the cosmos can be understood through observation and measurement. This is the heart of science, advancing not through speculation, but through data. Thanks for joining me on this incredible journey following 3IATLAS. If you found this as fascinating as I do, please hit that like button and consider subscribing for more deep dives into the wonders of our universe. See you next time.